Okay, good day. This is AP Calculus Summer Review. I am Mr. McCulley, and this is SR number 8, trigonometric functions. Let's get right into it. Okay, today we're going to talk about finding the sine, cosine, and tangent values of angles on the unit circle, and we're also going to evaluate trigonometric functions using the unit circle. This is certainly something that we spent a lot of time in pre-calculus, and hopefully just jogging your memory and bringing this back to your attention. So, what is the unit circle? You are going to see the unit circle quite a bit in AP Calculus, and it's going to be not necessarily a topic, but it's going to be something that the authors are going to expect you to know. And so they're not going to spend a whole lot of time on it. So I really would prefer that you took some time to go back and memorize your unit circle so that you have it down, because when you see what's the sine of pi over 6, and if you don't see that it's a half because that's your math facts, you're going to struggle, and they're just going to throw them at you at random. So it's best that you get this down now. And so let's talk about what the unit circle is and kind of go over a quick review. The unit circle is a circle of radius 1. So when you look at this circle right here, you are literally looking at a circle that has been put on a standard Euclidean plane. And every radius of this circle is 1. So this point right here is literally 1, 0. It's a little hard to see on this one. But just as a reminder, if you go to my page, I do have a printout version of this that you can use to follow along with. You might want to do that. All right, now, why these angles? Why are just these values when obviously we could draw a lot more lines and a lot more radii? Well, it's been divided into what we're going to call common angles, and these are angles that you are going to see day in and day out, and they have applications in other fields than just say mathematics. For example, construction uses 30, 45, and 60-degree angles. If you are doing projectile motion in physics, the optimum angle to shoot a projectile to make it get the furthest distance is 45 degrees. So these things do happen over and over. And while we're talking about it, let's also talk about these two sets of numbers right here. On the left-hand side, we have a bunch of radian measures. And on the right-hand side, we have degree measures. Now remember, all the way around the circle in degrees, which you learned since probably second or third grade, is 360 degrees. Now, in radians, and remember, we have to use radians because calculus doesn't work in degrees. It only works in radians. And so radians measures the same thing. It measures one revolution about the circle, and it goes, instead of from 0 to 360, it goes from 0 to 2 pi. And all of these divisions are multiples of these numbers, either pi over 6, pi over 4, pi over 3, or pi over 2. Now, pi over 2 is just a multiple of pi over 6, pi over 6, 2 pi over 6, 3 pi over 6. But in general, these are what I called the quarter turns when we were talking pre-calculus. So 1/4 around the circle was pi over 2. 2/4 around the circle is just pi. Now, memorizing these things are essentially your math facts for trig. It is exactly the same as the fact if I said what's 4 times 4, in your mind you're thinking 16 right now. You need to understand that at this point we really want, or if you're not, you want to get to a point where when I say pi over 3, you want to be thinking 1/2 square root of 3 over 2. And that's just what you need to be thinking about. So it is very advantageous for you. Take some time, review this, and commit it to memory. All right. So why does the unit circle work? Well, it works based on the cancellation principle in the fact that whenever you put a number over 1, so if you say, if I were to say reduce the fraction 3 over 1, well, 3 over 1 is just 3. And the unit circle works because sine and cosine and secant, or cosecant and secant, all have the hypotenuse in there. So having a value that is 1 allows us to reduce a lot of these and just read the values in the circle. So what do I mean by that? Well, let's say we're looking at this diagram right here, and this angle ends up being a pi over 6 angle. Well, we know that this distance right here is in fact 1 unit because it is on that unit circle. So since it's a radius of that unit circle, the length of this radius is 1. But it's also the hypotenuse of a right triangle to this point. And this point, its x-coordinate is the distance away from the origin. This y-coordinate right here, this y-coordinate is its distance above the origin right there. So when we talk about trigonometry, our SOHCAHTOA rules, the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is sine over cosine. So when you look at this expression and you say, okay, if I'm solving for y, what do I know? Well, I'm looking for y. I know the angle and I know the opposite side, or the hypotenuse. So I know theta, I know hypotenuse, I'm looking for the opposite. But the cool thing is that if you notice, it becomes y over 1 because I know that my radius is 1. So y divided by 1 is just y. So in actuality, in the unit circle, this angle measure, if you take the sine of it, it reduces down to the y value of the point on the unit circle. And that works for all of these things. The tangent, it reduces down to the y over the x. The cosecant, 1 over the y. The secant, 1 over the x. And the cotangent, x over y. So how are you going to be expected to use that? Well, I'm going to do a couple of different things. Now, ideally, you're going to have this picture memorized in your head, and you're going to be visualizing it. And when you do the practice work, I suggest that what you do is you take some time to memorize this unit circle here, and then try them on your own, and then check them. All right, I'm not going to begrudge you checking your work, but you really, really, really need to try and make sure that you understand it. So let's talk about this first example here. I'm trying to find the sine of 7 pi over 6. Now remember, on the last page, sine is the y value at this angle measure. So visualizing that, you should say, all right, where is 7 pi over 6? I start at 0, I come over to here, and here's 7 pi over 6. And what the unit circle allows us to do is we said that the sine was the y value. Well, the y value is right there. So what I can do is I can say that the sine of 7 pi over 6 is this y value. So I'm just going to plug it in and say it's negative 1/2. The tangent of 3 pi over 4 is literally the sine of 3 pi over 4 over the cosine of 3 pi over 4. Now we also said that the value was the y over the x. So in your head, what you want to visualize, you want to have that unit circle picture in your head, and you want to go to 3 pi over 4. Remember what the y value is, remember what the x value is, and write them down. So just as, again, we're visualizing this start at 0, go to 3 pi over 4. Well, the y value is square root of 2 over 2. The x value is negative square root of 2 over 2. So what I'm going to do is the y value was square root of 2 over 2. The x value was negative square root of 2 over 2. Now when you get the same thing divided by the same thing, it's just 1. And positive divided by a negative is negative. So this reduces down to just negative 1. All right, the secant. Remember, secant right here is 1 over x. So And it's also 1 over cosine. I suppose I could put those in there. This is also equal to 1 over the sine of theta. This is 1 over the cosine of theta. And this one here, I have it, so we're good. All right, so I can think of this as 1 over the cosine of pi over 3. And again, I would rather you not look at your unit circle to get this, but this is the visualization, and the only way I can show it to you is by going back to the picture. And what we want to do is we want to say, okay, it's 1 over, well, what is the x value at pi over 3? So I come up to pi over 3, it's 1/2. So I have 1 over 1/2, and when I divide 1 into halves, I get 2 parts. And if you don't like that, it was 1 divided by a half, which would be 1 over 1. Let's do it again. 1 over 1/2 would be equal to 1 over 1, because 1's the fraction 1 over 1 divided by a half. And when you divide two fractions, you multiply by the reciprocal. 1 over 1 times 2 over 1. Everything cancels. You're left with 2 over 1, which we said is just 2. That's how I get that. Okay? Now, let's talk about inverse trig functions. And you're going to use your inverse trig functions to figure out what the angle measures are. Now, I don't have a whole lot, I'm not going to take a whole lot of time to go over it, but here's I'm going to show you the graph of the sine function. And I'm going to show it to you over negative 2 pi to 2 pi, and that's, remember, 3.14, so 3.14 times 2 would be 6.28. So from negative 2 pi to positive 2 pi, and this is pi over 2. So basically we're going quarter turns on the unit circle. Now if you look at this graph of just the sine function, you will see that it is in fact periodic. So it repeats. It is not a one-to-one function. So what they did is they limited the domain of this thing so that it encompasses all of the possible outcomes. And they said, okay, if I look from right here to right here, and this is at this is negative pi over 2, and this is positive pi over 2, I have all of the possible y values that come out. So when I talk about limiting the domain for the sine function, the inverse trig functions only go from negative pi over 2 to pi over 2. The cosine functions only go from 0 to pi. The tangent functions only go from negative pi over 2 to pi over 2. And we can see that fairly easy. If I change this equation to the cosine of x and hit graph, all right, you'll notice if I go from negative pi over 2 to positive pi over 2, I only get positive values and it's still not 1-to-1. So what they did is they shifted it over pi over 2 units, and if you go from 0 to pi over 2, you get all of the possible outcomes on the cosine curve. The same thing holds true when you do tangent. So if I do a tangent x and you look at that, yes, it's a lot different than the other two, but notice from negative pi over 2 to positive pi over 2, I have all of those possible y outcomes. All right, so let's say I said find the cosine of, or find theta when cosine of theta is equal to negative square root of 2 over 2. Now, again, how do you do this? You're visualizing it. You should be having that unit circle in the back of your head, and you should say, all right, cosine. And you know what? I'm just going to kind of draw a little visualization without going back. The x value, cosine is this is the x value of some angle. Well, where is the x value? It's negative, so right here, if I go negative square root of 2 over 2, well, on the unit circle is going to come out a little further. It's more like an egg, but we'll get there. On the unit circle, there are two values where you could possibly have an angle measure that gives you the x at negative square root of 2 over 2. But remember, the values that are valid for cosine go from 0 to pi. So I cannot choose this one because remember, we are only going, let me change my line thickness just a little bit. We are only going from 0 to pi. This one is, this angle here, if I were to draw it in, that's going to be bigger than pi. So it's going to be bigger than our valid values. So we know that it has to be this one right here. That's the one we're looking for. So I asked myself, what angle measurement gives me that x value? Well, again, we'll go back and you'll see that the x value of negative square root of 2 over 2 is at 3 pi over 4. So the solution to this one is just 3 pi, or excuse me, we should write it correctly. Theta equals 3 pi over 4. Now, the tangent, let's talk about this one. Let's erase. Think about this one. Tangent of square root of 3. Well, remember that tangent only goes from negative pi over 2 to pi over 2. And so when we're thinking about that, this is pi over 2 if I open this direction. And if I open this direction, I'm at negative pi over 2. So since this is a positive number, we know that none of these values down here can be our measure for theta. And we know that because in the fourth quadrant, the x values are positive, but the y values are negative. So when we go y over x, we're going to get a negative value. So what we're looking for is an angle measure where the ratio of the y to x is square root of 3. Now, the only way you can get that is if you are talking one of the two values, either pi over 6 or pi over 3, because they're the only values that have pi over 3. And since I want it to reduce down to pi over 3, I'm going to need that pi over 3 on the top. So I'm looking for square root of 3 over 2 all over 1/2. So, and the reason I'm doing that is a square root of 3 over 2 all over 1/2. You're dividing fractions, square root of 3 over 2 times 2 over 1. Those cancel. I get square root of 3 over 1. I get square root of 3 right there. So I am looking for a y value for square root of 3 over 2 and an x value for 1/2. So we are looking at, let's close this. Let's close that. I am looking for this angle. There's my y, square root of 3 over 2, and half for my x value. So my theta is pi over 3. So the solution to this one, theta equals pi over 3. All right, last one, cosecant. Remember that cosecant theta is 1 over the sine of theta. So that's equal to 1/2, or excuse me, did that wrong. I got ahead of myself. I'm going to do that eventually. Come on, eraser. All right, is sine, so that's still equal to -2. If I take the reciprocal of both sides, I'll get sine of theta on top, and if I take the reciprocal of -2, I get -1/2. So I am looking for an angle measure, and again, from negative pi over 2 to pi over 2, where the y value is -1/2. Now remember, we're only going from pi over 2 to negative pi over 2, so I'm looking for the y value of -1/2, and I find it right here. So we can think of it, and again, we're not thinking of 11 pi over 6, although if you take the inverse sine of 11 pi over 6, you will get -1/2, or if you take the sine of 11 pi over 6, you'll get -1/2. We remember that we can either go from negative pi over 2 to positive pi over 2. So when I do in fact move down this way, I am moving in a negative direction. All right. So I'm not moving to 11 pi over 6. I'm moving negatively 1 pi over 6. So this is the same as negative 1, just negative pi over 6. And that is going to be my solution for this particular one. Actually, keep screwing that up today. I don't know why. Anyway, theta equals negative pi over 6. All right, there, folks. That is the end. And as always, if you think I made an arithmetic error or if you have questions, please feel free to give me an email using the address that I gave you on the summer syllabus, or please feel free to leave a comment in the section below. And as we are finishing up, we are at the Star Wars fun fact of the day. James Earl Jones is the voice of Darth Vader, but he was not in the costume. The man who was in the costume was a Scottish bodybuilder with a very thick accent. His name was David Prowse, and he was not real happy when he found out that they weren't going to use his voice. But wouldn't that be a very different movie if Darth Vader sounded more like Shrek than what we have come to know as Darth Vader? Well, folks, it's 21 minutes. That's all I have. You guys have a great day, and we are almost done. Only 2 to go.